Thank you very much for sharing. So whatever is your number of years of experience, we have formed this world's largest community of lean champions, wherein we want your contributions also inside this group. Okay. So thank you for sharing your industry. Thank you for sharing your experience. What is your role in your company, your designation? You might be a supervisor, manager, senior manager, or you might be a business owner, CFO, whatever. So there are directors here. Mr. Nandakumar is a director. Welcome, sir. Mr. Abai. Mr. Gonzalo is CEO. Welcome, sir. And Abhijit Konar is CFO, head of the department, HR managers, admin, GM quality. So sincerely welcome each and every one of you. There is director quality and compliance. Fantastic. Okay. So a warm welcome to each and every one of you. There are students also here. So whichever place you are in, we all know that this Lean Six Sigma is applicable at all levels, and that's why I formed this world's largest community of lean champions inside Telegram. Go ahead and be a part of it. There are over 13,000 people as of now. Okay. All right. So last few questions. I know people are from all around the world who have logged in. Okay. So can you please share people who are from outside India? People who are from outside India, please share the name of the country that you have logged in from. Only people who are from outside India, because still, even after saying that, some people will type India. Please don't type. Okay. So we have people from, let me read, we have people from the UK, the US, Pakistan, Bangladesh, Indonesia, US, Costa Rica, Italy, Canada, Germany, Egypt, Pennsylvania, Mexico, Bangladesh, Oman, Nigeria, okay, Jordan. There are a lot of people from Canada today, okay, Austria, okay, people who are from outside India, I said, okay. All right. Okay, right. Thank you very much for sharing, and sincere welcome to all the people who are from all around the world. The customary welcome is we send you flowers like this, okay? We send you flowers like this. So I sincerely request people from India to send them a lot of flowers today, okay? From people. This is a customary welcome from India. Mr. Malin Kulkarni, thank you for that. Okay, let's see who sent maximum flowers today, okay? Shaktivel, thank you. Bala Sahib Hijri, thank you. And people from all over the world, you may want to acknowledge these flowers by saying thank you or whatever that you feel like, okay? Thank you very much. Fantastic. That's nice. Nice to see this. So let us start with this high energy. My name is Murli, and I have logged in from this beautiful city of Bengaluru in India. Which city in India have you logged in from? Let us see from the chat box. Chennai, Shaktivel, eppadi irkeenga? Indore, kaise hai? Okay, people from Bangalore. Chennai gidira, Utaita. People from Kerala, Unuvainyo. People from Andhra, Bagunnara. Hi, people from Maharashtra, Kaisala. Kaise aahe? People from Pune, okay. People from Gujarat, Kemcho, Majama. Tabiyat Pani. And people from North India, kaise hai aap log? Badhiya hai. Okay, thank you very much. And you can type welcome in your language, okay, to all the people here, and let us jump into the session. Thank you very much for sharing this, okay. Andanam, Swagatam, Vanakkam. Okay, Mabuhi, Salam, Swagat. Fantastic. Okay, thank you very much. So let me jump into the session today. And with that, let me share the screen. All right. Thank you. Thanks each and every one of you. And what I want to share here is over the last 3 years, more than 3 years now, I've been coming online and sharing this great methodology called the Lean Six Sigma methodology. And there is a format for it. And what I'm teaching here is Lean Six Sigma Green Belt. When the COVID came, I was inspired by this quote. When you have something to share, you can improve the life of others. Education is for improving the life of others. And you can leave a better community. Okay, and you can leave. I was inspired by this quote. I was also inspired by great Nelson Mandela, who said education is the most powerful weapon which you can use to change this world. Okay, so a quick housekeeping before we start. So we are close to 1,000 participants, and if you get logged out, make sure that you try logging in, because if somebody logs out, you can get a slot inside. This is held every Wednesday for 1 hour. Kindly mute your phones, ask questions only towards the end. Kindly attend all sessions, be on time every time, respect queries of everyone, take good notes, make relevant comments. And here in this session, I don't want anyone to be in a hurry, because I will take this session in my own style and my own pace. Okay, if you have any priority work, if you are listening, you can carry on with your priority work. Okay, and avoid social media distractions and avoid posting unnecessary contents in the chat box. Okay, so one last time, I wanted to welcome each and every one of you to this world's largest community of lean champions. If you really are serious about your career, if you're serious about solving problems in the workplace, then this is the community you have to be in. If you can't, if the link doesn't work, then you have to copy this link inside Telegram and save the messages, or send it to someone and click from inside, and you'll be able to join that. Okay, I'm inspired by this quote. The major value in life is not what you get. We might get a car, we might get a bungalow, we might get anything, but the major value in life is what you become. So when people enter my sessions and when people go outside my sessions, I want people to become more valuable. If you like this quote by Jim Rohn, please give it a thumbs up, because this is one of the most inspiring quotes for me. So we should constantly look at adding value for ourselves. Okay, we'll have to increase our value for ourselves. Fantastic. Thank you so much. Great. Okay, thank you very much. So for those who are here for the first time, let me quickly introduce myself. My name is Dr. Murli. People call me Lean Murli because I'm the Lean Master Coach. I'm the founder director of a company called Value Enablers Academy. At Value Enablers Academy, we are specialists in Lean Six Sigma and Kaizen. I'm on a mission to help 1 million passionate professionals become lean champions. How many of you are with me in this mission? Type WU in the chat box if you're with me in this mission. Thank you very much. So I studied in premier institutes. It's called IIM Bangalore, Indian Institute of Management, and BITS Pilani, Birla Institute of Technology and Science. And I also did my statistics and master black belt from world's renowned institute called Indian Statistical Institute. For the first 15 years of my career, I worked in large organizations such as TVS, Saint-Gobain, and Jason's at very senior management positions. That was first 15 years of my career. In the last 12 years, so totally 27 years, we at Value Enablers Academy had the opportunity to visit organizations across industries. Some of these industries are given here. Some of these organizations and logos might be familiar to you. And this is this wealth of information that I'm willing to share with you today. How many of you are eager to learn? Just type ETL in the chat box if you're eager to learn. So a quick check before we start, okay? A quick check before we start, just to check whether it is for you, okay? How many of you have higher salary expectations? You can check whether this is for you, otherwise, you can carry on with your priority work. How many of you have higher salary expectations? Type HSC in the chat box, higher salary expectations. How many of you want to improve job prospect? Type IJP in the chat box. How many of you want to enhance your on-the-job experience? You can type OJE in the chat box, on-the-job experience. There might be somebody who wants to increase value to your employees. You can type VE in the chat box. And if you're looking forward to movement into managerial roles or higher roles, you can type HR in the chat box. Whether you have higher salary expectation, improve job prospects, on-the-job experience, increase value to the employers, or movement to the managerial roles, this session will help you. Okay. So what I've done is, What I've done is I have curated this session. This session is absolutely free. I'm not going to sell anything on you. This session, you can attend 50 sessions absolutely free. Okay. And there are a lot of people who have attended this session, enhanced their learning, applied in your workplace, and I'm thankful for that. But then there are some people who ask, Murli, I wanted to do it faster, 50 days, in 50 days. Okay. So I have curated the content into 50-day plan for you. There is a 50-day plan for you to do this course. Okay. And this, after you do finish the 50 days, you have to write one exam and you can get the certification, which is accredited by Six Sigma Council from the USA. We call this as Career Acceleration Program. Okay. And what we do in this program is, it is based on 3E model. We give education, we put you in the right environment, and we give you the right experience. Of course, education means you'll have world-class content in the form of video, audio, you'll have presentations, you'll have case studies, articles, all that. Okay. And you'll be put into right environment of experienced team, qualified members, question and answer session, job posting, panel discussions. And you'll also attend some exclusive live sessions, mock test, quiz challenges, interview questions. If you are interested in knowing about the 50-day plan, type 50D in the chat box. In case those who want to know about this, type 50D in the chat box. This is only for people who are actually serious and who want to become number one, who want to achieve excellence. Okay. So what I've done is, you will find that this is one of the most affordable programs, most comprehensive, best of best knowledge. Okay. You will have quiz, exhaustive interview questions, okay, placement opportunities and all that. Okay, if you're really interested in this program, what I'll do is, I will just share with you for you to come to my upcoming webinar. Okay. Okay, this is a special session, okay, in the upcoming webinar. So when you click on this, you will get a screen like this. Okay. When you click on this, you will get a screen like this. Okay, let me close all this. You'll get a screen like this, and then you can register in this. Okay. Okay, so what I'll do is, I'll give you a maximum of 3 minutes, because when you come back, I'll start my session on practicing CP and CPK. Okay, how to practice CP and CPK. So go ahead and just register in this. And when you join this webinar, inside this webinar, there might be some people who might have suppose if this session you're coming late, you skipped the sessions, you wanted the recordings. I will tell you how to access these recordings. And I will take you step by step onto how to accelerate your career. Okay. I will talk about, where the economy is heading towards, so that you get excited about this growing economy. I'll talk to you about how various countries are investing. I'll talk about how various companies are investing. And also, you'll find that I'll also show you from different job portals the amount of opportunity that is available for Lean Six Sigma professionals, particularly this professional. Okay. And it's very important that you understand that this is applicable in all industries. I will talk about the evolution of different standards. Okay. We all know ultimately we need to improve our processes. Okay. We will all have heard about ISO standards, QS standards, TS standards, and all that. And finally, we've heard about Six Sigma standards, okay, Lean standards, Kaizen, okay, continuous improvement, theory of constraints. So I'll touch upon all these topics. I will also give an overview of the DMAC methodology, the define, measure, analyze, improve, and control. And I'll share with you different people in different industries, how they have applied and got benefited. Okay, there are some people from pharmaceutical industries, there are people from construction industries, there are people from education industries, there are people from IT industries, there are people from financial sectors, there are people from BPO sectors. Okay, there are people from HR professionals who have applied this. I will share with you all that case studies. Okay, tomorrow in the upcoming webinar. Okay, um, so it's going to be really interesting. You will get inspired. I will also share about my story of how, you know, I came long way over 27 years. Okay, what are the ups and downs I faced? And particularly if you're interested to take this as a profession, like you wanted to become a trainer, consultant, coach, okay, then that is my, actually, I want to create the world's largest community of trainers, coaches in Lean and Six Sigma. I want to create the world's largest, because there are a lot of small and medium enterprises. There are a lot of small and medium enterprises who are struggling to get growth and profit. Okay. And the world needs you, each and every one of you. And that is why I know that I have implemented this practically, and the companies have got benefited. And you can also become a trainer, you can also become a coach, and you can also benefit a large number of people. Okay. How many of you are excited? Let's see how many of you are excited. Type XITD in case you're really excited. Okay. And I'll jump into the session for today. Okay. Great. All right. So with this excitement, let me start. I will be modulating my voice. Okay. Whenever I get excited, I go on the top of my voice. Okay. That's my style. Okay. Thank you so much. Thank you so much. Thank you so much. So I invite each and every one of you who are not a part of my inner circle to come to this upcoming webinar and be a part of it. Okay. All right. So the capability roadmap, how many of you are here for the first time? Just type FT in the chat box if you're here for the first time. If you're here for the first time, just type FT in the chat box. Okay, there are a lot of people who are here for the first time. For people who are here multiple times, type MT in the comment box. Not EMTUI, okay? M and T, multiple times. Okay? Okay. People who are there multiple times, if you found my session interesting, valuable, useful, awesome, fantastic, fabulous, whatever that you felt, please share in the chat box. I'll draw inspiration and jump into the session today. Okay. Okay. Now, anybody who has missed it, stupendous. I like that. Okay. Thank you so much. Thank you so much. Each and every one of you. Thank you so much. All right. So let me just pause the chat. Now, please understand. Please take good notes. Now, you need to have a goal. Now, capability roadmap we have saw. I'll just do a quick recap of last session so that there is a continuity. Okay. You have to define goal. Once you have the project, you need to define the goal, and you need to be very clear with what do you define as unit. Okay. Suppose if you are finding out errors in invoices, the invoice, the purchase order or the invoice copy is your unit. And you need to be very clear about the defect. For example, the quantity there, okay, is wrong. So quantity is a defect, or the name of the supplier, whatever that you have done, is a defect. So you need to be very clear about the defect. Okay. Then you collect the data, and in one of the sessions we have already learned, don't worry about if you're new to the session, just to be there and absorb the contents. Okay. There is an attribute data and continuous data. All of you type AD and CD in the chat box. Attribute data and continuous data. Attribute data is nothing but, okay, attribute data is nothing but like number of invoices, okay, number of invoices, or number of defects, or defect type, okay. Whereas continuous data is something like weight, height, temperature, pressure, because the data is continuous. Between any two data, there are million data points. Okay, infinite data points, not even million, infinite data points. Okay, so if you want to understand deeper into attribute data and continuous data, I will share the recordings. Please register in my upcoming session and I will share with you how to access these recordings. Okay. So we already got into, when it is an attribute data, we already calculated and practiced DPU and DPMO. How many of you were there during that session? Type me in the chat box if you are there, where we, practiced. Fantastic. So today we are going to practice. Fantastic. Superb. Superb. Thank you very much for all of you who have attended that session and coming to this session. Fantastic. Superb. Okay. Now we are going to, for the continuous data, we are going to calculate what is called a CP-CPK and PP-PPK. All of you write in your notebook, CP and PP. That alone is sufficient as of now. CP and PP. C stands for capability. P stands for performance. All of you write in your notebooks, performance and capability. C stands for capability and P stands for CP is process capability, PP is process performance. CP is process capability and PP is process performance. So performance and capability of the process. If this is clear, because a lot of you will have a doubt, what is CP and what is PP? I've heard many people don't able to exactly say what it is. If it is clear, so, okay. Mohammed Yusuf, I'll repeat for one more time for you. Process capability and process performance. Okay, process capability and process performance. Clear? I'll come to PPK and CPK later. I have asked you to write only PP and PP. Okay? Super. Fantastic. Okay, don't worry. In case if you want to learn more, register in this upcoming session and I'll share with you the recordings and you'll be clear about that. Okay, now, suppose there is a truck that is to deliver, okay? And the customer desires the time of 11 hours and you can be 90 minutes earlier or late. They are willing to accept that. If you are a customer, assume that you are willing to accept 90 minutes early or 90 minutes late. Okay. So what is the specification? Please type in the comment box. This example we saw last time, just quick revision. Okay. What is your upper specification limit? What is your upper tolerance limit, lower tolerance limit? Okay. Yeah. 9.5 to 12.5. Okay. 9.5 to 12.5. So let us say we collected this truck driver, this truck, we collect the data for 50 deliveries, okay? 50 deliveries. Let us graph it and see whether we are able to judge how well this is doing. We need to answer this question, okay? Are we really averaging 11 hours for each delivery? Because the customer desires the delivery time of 11 hours. So are we really averaging 11 hours is what we need to do. What is the chance of delivering too late or too early? What is the chance for delivering? Now, if you see here, there are the x-axis has got a time. This is the delivery time. The unit is in hours. 9.5 hours, 10 hours, 10.5 hours, 11 hours, up to 13.5 hours, and so on and so forth. All right. Now, customer specification, as you rightly said, it is between 9.5 to 12.5. All of you have already typed in the chat box. Fantastic. Now, the target is 11. Okay, the target is 11. Now, if you calculate the average of this, all of you make a judgment. Where is this average? This is the peak is the average. Where is this average? Where is this average? Approximately, you can tell me. Yeah, somewhere around 11.7 or 11.8, right? Somewhere around that. Okay, that's what is the average. And do you see deliveries going greater than 12.5 hours? Do you see the delivery greater than 12.5 hours? And this is called as a defector, right? So this is the place. Even though the average is inside, even though average is 11.7, there are a lot of instances where it is outside the required limit, tolerance limit of the customer. We call specification limit. Okay, so now the question is, how this process is performing with respect to customer requirement is a question we need to ask. The mean is now 11.66 here, to be precise. Okay, all of you judged that it's 11.7. Okay, now is the, I just looking at the graph, I want you to answer whether this process or this delivery, this truck delivery, is he capable or not capable? Tell me, is he capable or not capable? Incapable, partially capable. Okay, so the answer what you gave is called binary data. All of you type BD in the chat box. This is called binary data. Okay, see, you either judged it is capable or not capable, and somebody put partially capable. That is called ordinal data. All of you type OD in the chat box. OD, ordinal data means in order. That is highly capable, capable, partially capable, not capable, miserable. This is called ordinal data. It is arranged in the order. But here what we are going to see capability, it's a continuous, time is a continuous data, and hence we are going to give it a number. We are going to give it a number. We already said you have a bandwidth. Okay, we are going to give a number. You are having a track or a bandwidth, and you have to drive inside the track or perform inside the track. If you're in the running race, you will be given a track. You're not supposed to go to the next track. Swimming also, you have a track. Similarly, you have your own track. You're supposed to go in your track without even, dashing with someone else. And it should be well within the track and better to be centered in the track. Okay. If it is clear, type super clear in the chat box. SC in the count. SC means super clear. Okay. So similarly, if your track limit is given as 9.5 to 12.5, you want it to be well within. Suppose if your track is 9.5 to 12.5, how much you should be within so that you are very safe? How much you should be well within? Just I'm asking for you, opinion of people. Okay, if it is 9.5 to 12.5, give me a band. Somebody is saying 10 to 12, good. 10 to 12 is good. 10.5 to 11.5 is very good. Always if you're 10.5 to 11.5, it is very good, right? But it's very difficult to achieve that, right? Like strictly within. Okay, no problem. Fantastic. Okay, some of you said I missed the previous session. Don't worry. You come to this upcoming webinar, I'll share with you the recordings, okay? Okay, now, what we are going to say is, we are going to see some indices for this. These are all called capability indices, okay? The index or indices. We'll assess the process capability, how it is performing with respect to customer requirement. It is also possible to convert that into DPMO. That is a deeper topic, I will discuss about that. Fantastic. Okay. Now, voice of the customer, all of you type VOC by VOP. Okay, all of you type VOC by VOP. Voice of the customer, which is a specification limit, and voice of the process, which is what it is performing, how the process is performing. Okay. Or in other words, total tolerance. For example, in this case, it was 12.5 to 9.5. That was the total tolerance, whereas the process was spread more than that. The process was spread more than that. Or in other words, this formula you need to remember, LSL minus USL divided by 6 standard deviation. How do you calculate standard deviation? I'll give you a formula for that. Okay, and most of the time, the computer automatically calculates the CP also. Okay, forget about standard deviation. The computer automatically calculates CP also. But all you have to remember is how to interpret this CP. An illustration of CP is like this. Okay, an illustration of CP is like this. We already said that it is upper specification limit. In this case, it was 12.5. Lower specification limit, which was 9.5. And somebody has to tell us what is the 6 standard deviation. Like standard deviation, we can multiply by 6 and we can always calculate CP. It is just mathematics, right? But what I want you to understand is, if your process spread is more, if the denominator is more, then what would be the CP? Will it be greater than 1 or less than 1? Suppose if this deviation is more, okay, the bottom is more, it will be less than 1. That is what I want you to remember. In this first case, the deviation is much more than the specification or tolerance limits, and so it is less than 1. Okay, let's say that it is double, and so it is 0.5. Okay, now if it is exactly same, if numerator is also same, denominator is also same, what will be the CP? Exactly 1, right? That's what I want you to understand. That means you're exactly driving on the track. One tire is on one white line or yellow line, the other tire is on other white line or yellow line. Assuming that you're exactly traveling there. Or even if you're in bike, you're going here and here, you're going to that side and coming here, going to that side and coming here and stuff like that. Okay, wobbling. Suppose if it is much inside, will it be greater than 1 or less than 1? If you're, it will be greater than 1. Fantastic, right? Super. Suppose if it is like this, okay, what will it be? 2. Fantastic. Greater than 2 also. Okay, much better than this. Okay, this is 2. So if this illustration was fantastic, fabulous, useful, awesome, etc., whatever that you felt, put it in the chat box. Let's get a lot of excitement today. Okay, let's go further. Okay, fantastic. Now I'll show you a trick. Okay, suppose, okay, thank you very much. Thanks everyone. I'm also excited. Okay, I'm also excited. Okay, so suppose if this is a lower specification limit, this is an upper specification limit. Assume that the process is inside. I'll give you a number. Okay, this lower specification limit and upper specification limit, let's say it is 4. Okay, or let us say the upper specification limit is 10, lower specification limit is 6, and the difference is 4. Okay, and assuming that 6 times standard deviation we had calculated by the formula, it is coming to 3. So what is the CP in this case? Let's see how many of you type quickly. What is CP in this case? 1.33. Okay, fantastic. 1.33. Okay. Okay, fine. Thank you. Now my question here is this. Okay, my question here is this. The 6 times standard deviation does not change. Okay, the variation remains the same, but the average alone has shifted. Can you notice that? Type yes in the chat box. Here in this case, the average was here and this average has shifted from here to here, right? Will the CP change? Yes or no? Will the CP change? Yes or no? Okay, that is what you should remember. That is the biggest learning you should take. CP will not change because the variation is the same. 6 times standard deviation is the same. Many people are asking why 6 times standard deviation. All that I'll explain later. Okay, that is too early for you now. Okay, because it does not depend on average. Do you find average in this formula? Do you find average in this formula? You find lower specification limit, you find upper specification limit, you find standard deviation. But average does not So CP does not consider the average. If this is bulb bond for you, type BO in the comment box, because this is a new learning. Okay, if it is bulb bond for you, type BO in the comment box. So that is why CP is going to remain the same. Now, that is why CP is not a good indicator, because it does not tell you that process has shifted. It does not tell you the process has shifted. Look at this. The process has shifted in such a way that the average has become the lower specification limit. What is the CP in this case? What is the CP in this case? Same, because it does not include the process shift. It does not consider the process shift. And so CP remains the same. So CP is not a good indicator. It is necessary, but not sufficient. Can you please write in your notebook, necessary, but not sufficient? Okay. Now, there must be some factor which will take care of this shift. Okay. Let me get into the detail. Like, for example, car is being parked at the center. We should also see how close it is on left side or how close it is on right side. Suppose you take half the car, and wherever is the lowest distance, that is what you should decide the capability of the driver. You should not, please understand this, you should not decide the capability of driver by seeing the side of the wall where there is more space. You should decide the capability of the driver by seeing the side of the wall that has got less space. How many of you agree with this? How many of you understood? You should decide the capability of driver based on the wall where there is less distance. That is what is true capability. His true capability is not whether he has parked inside the garage. You should see how close to the wall, how close he has gone to the wall, because your car might get scratched. So his capability is to ensure that he must, which side is very close to the wall, and that is what is his capability. Okay. So what we are going to do, so we'll decide the closer he is to the wall, that means he is not capable. The farther he is to the wall, he is capable. But if he is farther to the wall, the other wall will be closer. So that closer wall we will consider for his capability. How many of you understood? Just type US in the comment box if you understood. We will consider the closer wall. And if he is farther, he is good. But then we will also see the other wall. If it is closer there, then again he will say he is not capable. Fantastic. I'm so happy that a lot of you understood, because this concept, if you are understood, then we can go to what is called CPK, Process Capability Index. This is called Process Capability Index. K is for index, okay? Accurate and precision. Fantastic. Okay. Super. Very good. Now, we'll use the same. See, from the center line, he has to come. This car midpoint should always come to the center line. The car midpoint should always come to the center line. That is the ideal way of parking. Similarly, when we see the process, we not only see the voice of process, customer by voice of process. What we do is we take average into the consideration. Instead of 6 standard deviation, we'll take 2 standard deviation. Instead of, we will break that normal distribution into 2 halves. 1 half of the average and other half of the average. We'll find out the average. Okay. From average, how far it is into the, like for example, the same thing, the car, same thing with the car. Okay. This car, this center point, okay, how far it is from the right side wall, the center point, how far it is from left side wall, and whichever is lowest is his capability. Okay. Similarly, center point is the average and lower side is lower side of the wall, and center point is the average here, upper side of the wall. We will calculate both and we will see which wall he is closer to. That is the minimum of this. And we will find out, we'll call him, it is that capability. Okay, this is not an easy concept to understand, but I would really get excited if many has understood. How many of you, if you understood on a scale of 1 to 10, please give me a 9 or 10 if you understood. Those who type 9 or 10, that means that, hats off to you. Because it's not a very easy concept to understand. Huh? You need to practice. Now, beyond that, if you've not understood, that means that you need still a lot more learning and practice to really understand. Okay, great. I'll come to you with examples, practice examples now. Okay, that is what is the objective of today's session. Okay, so this ratio penalizes you for being off the target because it uses average. So it penalizes you for going off the target. Okay. Now we have said that, okay, upper specification limit. Now I'll explain to you what is stable process and unstable process. What is CP and CPK? We have already talked about common causes of variation and special causes of variation. All of you type CCV and SCV. CCV is common cause of variation. I'll tell you what it is. Okay. Common causes of variation means if you're making a batch of biscuits. Okay, fantastic. Just hold on. I want everyone to pay attention to this because there are students here, there are directors here. I want everybody to pay attention. If you're baking biscuits, one batch of biscuit will come out well and consistency might be good. Okay. But if you're baking several batches over a period of time, do you think which will be more capable process, one batch or many batches? Which will be a capable process? Which will be a better process, one batch or many batches? Okay, now this is a concept I'm triggering in you. See, many people say many batches, some people say one batch. Okay, let me tell you something. I'll ask you the question in a different way. All of you listen carefully. I've just paused the chat for that, okay? Where will be lot of variations in one batch or many batches? Type OB if it is one batch, MB if it is many batch. Where will be lot of variations? If you mix many batches, will the variation be more? Or if you have one batch, the variation of the biscuits will be more. Yeah, if there is many batches, the variation will be more. Why would many batches have lot of variation? Because the raw material will be different. The temperature settings might be different. The ingredients quantity might be different. So there are many factors when you do multiple batches. So this is called, there are various factors, correct. So this is called special causes of variation. There'll be a lot of special causes of variation. Whereas if you study only one batch, you will have less number of variations, less factors. That is called common causes of variation. Like Lydia Patterson said, the probability increases if you have many batches because there are many factors. If you have understood this concept on a scale of 1 to 10, please give me a 9 or 10. Then I'll explain you what is PP and PPK and what is CP and PP. Okay. Okay. Now, if it is common causes of variation, okay, there is a formula. And if it is both the common cause and special cause, there is a formula. Okay. Now, my dear friends, do not ask me why this formula and that formula, because it's a greater mathematical research which is beyond the scope of the subject. All you need to do is the software will automatically calculate that. The moving range average divided by D2, which is a constant based on the sample size, is something that I'm not going to explain in depth here. Okay. And you know the formula for this standard deviation, and I'm not going to explain this formula because I've explained in the earlier. But I want you to remember that the standard deviation calculation is different that the software uses, but it is just for the academic purpose. Okay, for the practical purpose, you will not use this. Please understand this. The software will give you. But what you have to understand here is this, my dear friends. I want you to understand that PPK is indicative of the unstable process. CPK is indicative of the stable process, which is, so CPK generally, when you make a study of one particular batch or one particular shift or one particular day, you call more as CP and CPK. Okay. If you take over a period of, so customer sees your performance, whereas when you conduct trials, you see the capability, because customer is receiving every month over a period of long time. So for customer, it is PP and PPK. How many of you understood? Only people who understood can type US. If you've not understood, don't worry. Because if you're a customer, you don't care which shift it is. You don't care which batch it is. You don't care which machine it is. It is, you see the overall performance of this company. Okay, fantastic. Super. Okay. If you've not understood, probably you are new to this field, or probably you need more experience in this. Okay. So in the dynamic process, if you see, the customer sees this line. Please understand this. The customer sees this. Now, this is called performance. Customer sees your performance because he has got many batches of your biscuits, many batches of your detergent soap, many batches of your pizzas. Customer sees your performance. Whereas when you see inside one batch of bread you bake, you have a lower specification limit, you have upper specification limit. Okay. So over a period of time, your process, this is say process is Y, over a period of time, it is very interesting to see. Okay, let me show you step by step. First, maybe day one, it is like this. Week one, it is like this. Week two, it is like this. Week three might be slightly shifted like this. Week four is shifted like this. Now, if this slide actually helps you understand, now you put all this together because the customer has got all the batches of your biscuits. And now customer sees this green color as your performance. Now on a scale of 1 to 10, please give me a 9 or 10 if it is clear. Fantastic. This is how you should understand. So individually you calculate CP, CPK, but overall SPP, PPK. Fantastic. Thank you very much, Ajay Sharma ji. If one person has understood deeply and got bulb on and goes here, my mission is accomplished. I'm telling you. Because I give my heart and soul to explain to you so that I want this to reach to each and every one of you. Okay. Good. Fantastic. Okay. Now, this is called as capability and this is called as performance. So those of you who really want to understand this in depth, step by step, because some has written, I've still not understood, and some crying symbol, like even I used to cry at the kid if I don't understand, right? So I see some emojis like that. Good. So what you have to do is, if you've not understood, that means that you need to put efforts to understand. Come to my upcoming webinar and learn from our community, learn from my teachings, go through step by step. I'll give you a 50-day plan to learn, okay, and get certification. People who said not understood, it is my responsibility to make sure you become master in that, not only get certification, but I will make you as a trainer, coach, consultant, whatever it is, provided you are willing to learn. You are willing to put that effort. A trainer can only guide you, but you need to do that workout. Whether you are willing to do that, work out. Okay. There are many people who join our community and they don't work out. They don't watch my videos. They don't watch the presentations. They don't come to my live sessions and stuff like that. Okay. This concept I'll explain little later. That is over a period of time, because of which so many special causes of variation, your capability will come down. The process will shift here and there. Okay. Now, you see the biscuits, for example, or the yield, whatever data that is weight of the biscuits, you can call this weight of biscuits also. Over a period of time, whatever is the biscuits that are coming out in the continuous baking oven. See, there are also continuous baking oven. Okay, there is a long tunnel and the biscuits, wet biscuits will go inside, and as it goes through the tunnel round and round and round and round, when they come out, they will get baked. Okay, so continuous, let's say the weight of the biscuits is like this. So this is plotted. Each and every weight of the biscuit is plotted. You can even put that as a tabular form. You can even put that as tabular form. And this is what in the curve we call it is a normal distribution. So these trains can be analyzed, variation can be analyzed. But what the customer sees is this, because there are many biscuits that are coming out, many chocolates that are coming out, many water bottles that are filled, whatever example you can take. But finally, the sum of all this is what the customer sees. Okay. Okay. I will explain to you with one more illustration. Suppose if it is a carbon dioxide level, for example, okay, CO2 level, oxygen level, nitrogen level, whatever it is. I'm just giving different examples so that suppose if one day CO2 level is like this, okay, the other day it is like this. Now, this particular week, if you see the CO2 levels, this is called as the capability of that particular period. Okay. But if you see overall, the capability is wrong. For example, one part of the day, for example, night time, the CO2 levels might be different. In the daytime, when the, the traffic is high and the pollution is high, maybe it is much higher. Correct? So these in the time order data, Okay, so this data shows that the process, if well controlled, can perform much better than currently it is doing, which means there is something that is going out here. There is something that is going out here. There is something this. So if the process can be controlled, the overall performance can be better. Okay. Now we will see this also. For example, the same illustration here. This is called, because only the common causes are short-term variability during that night time alone. Okay, carbon dioxide level. Whereas if you see here, this is an overall performance, maybe throughout the day or throughout the month, throughout the year, whatever that you see it. This is called as total variation, including shift and drift. So if this explains you a little more, and if some people have got clarity, you can give me a 9 or 10 if you got more clarity in terms of this graph. Okay. This is similar to the car. Okay. The shift and drift should be controlled within this wall. Okay. I'm bringing the same thing again and again. And that is why, if you see here, okay, that is why if you see here, the CP is 1.3. Okay. Whereas what will be, my question here is, here CP is also 1.3, CPK is also 1.3. And we have seen in the earlier slide that in this bottom graph also, the CP is still 1.3. What would be the CPK? Just guess the CPK. The average is closer to the LSL, is equal to the LSL. What will be the CPK? No, look at CPK here. X bar minus the average is now equal to LSL. Average is now equal to LSL. So average minus LSL, both are same. Great. So CPK is equal to 0. Please understand this, okay? CP might be the same, but CPK might be different. This is what we have to practice. We need to keep practicing. You have to understand the thing. So this way, what will be the CP? CPK. What will be the CPK? Less than 1. Fantastic. Okay, 1.33 here, this will be less than 0. So you need to practice this. Okay, we need to practice this. If you see the overall here, okay, if you see the overall here, we will have more practice examples also. I'll give you some values also we can practice. Okay, overall, if you see like this, you have lower specification limit, which is 500, and upper specification limit, which is 900. Okay. Here, if this is a sort of variation, the CP, CPK, PP, PPK might be the same because the overall process is equal to, okay, the localized process, because it seems to be the same pattern here. So it is possible that CP and PP are same and CPK and PPK are same. You just have to understand this concept because this is a quiz question. CP can be equal to PP and CPK can be equal to PPK. But the question here is, can CPP be more than CP? That is the question. Yes or no? Can PP be more than CP? Can the long-term capability be better than the short-term capability? No, it can be, because over a long period of time, it will always deteriorate. So CP is always greater than PP. Okay, CPK is always greater than PPK. Friends, please understand this is a compulsory question if you are writing exam. Okay. For example, okay, this is an indication of the stable of the target large variability. Don't worry about it. In this example, if you see, this is one. Now it has shifted. It has drifted. When it is shifted and drifted, the PP, the performance will come down. Here the capability is good. Here the capability is good. Variation is less. But overall, if you see, the variation has become more. That is why PP and CPK has become less. PP and CPK, PP and PPK, the P cannot be more than C. Because over a period of time, it will always deteriorate. Okay? It is always deteriorate. Okay. So shift is a special cause, average is close to the target, large variable. So this is the example that I want to share today. Okay. So, okay, since we have hit 9, I don't want to. We'll take this example in the next session. If it is okay, just give a thumbs up. We'll take this example in the next session. I'll give you some practical numbers like this and ask you to calculate. Okay, because I want to respect time of others. Okay. Okay, how many of you found today's session interesting, valuable, useful, fantastic, awesome, etc., etc.? Okay. Thank you very much. Superb, superb. Really, really, thank you very much, each and every one of you. So I also thank you for being in this session. I will answer the questions that you might have. And as I told you, these sessions are all absolutely free. Okay. You can come to this session, learn it, apply this learning. But these are all 50 weeks, okay, that you need to learn. If you're really interested in doing it in 50 days, I'll give you a plan. Okay, how many of you want to do it in 50 days? I'll give you the recordings, I'll give you a plan. How many of you want to do it 50 days? Just type 50D in the chat box. I'll also share with you the presentations, material and all that. Okay. Good. Okay, so I'll just pause the chat. You register for this upcoming webinar, and I'll tell you what I'll share here. I'll give you a plan to do it in 50 days. Okay, I'll give you day one, day two, day three, day four. Okay, and I'll tell you